Alright, question B3. So, let ABCD be an isosceles trapezoid with sides AB equals CD and parallel sides, and we have some side and angle conditions. So first, we can annotate our diagram. This is 10, this is 10. So we know that these two angles are equal. And also, it's given that these are parallel. So we can let angle CAD be x. So now since it's isosceles trapezoid, then this here is 45 plus x. And same here. So now we can solve for x. Since these three angles add up to 180, we have 3x plus 90 equals 180. So x equals 30. So now here we can do some clever construction. So since it's a trapezoid, we can draw a right triangle here and then paste that over here. So now let's call this E and F. So the area of the trapezoid is equal to the area of AFCE. This is a rectangle, so it's equals to base times height. We can use some trigonometry. We know that x is 30. So this is a 30, 60, 90 triangle. So we know that CE is 5, and then AE is 5 root 3. So now the area is just those multiplied together, which is 25 root 3. Alright, next we have question B4. So we're given that we want to solve for x so that the two polynomials are equal. So first we can set them equal. This means that p of x minus q of x is equal to 0. So let's let I and j be the indices that were swapped. Without loss of generality, we can assume that I is greater than j. So we can rewrite this as here we can factor, and since we know that the a's are distinct, it means that xi minus xj equals 0. We can continue factoring, so x of the j times x of I minus j minus 1 equals 0. So we see that when I minus j is even, so x can equal to 0 or plus minus 1. And when it's odd, x equals 0 and 1. So now we can start calculating the expected value. So in total, there are 101 coefficients. So there are 101 choose two ways. And then for the expected value of the desired ones, we can do casework on I minus j. So case 1 is when I minus j equals 1. So there are 100 ways, and since that is odd, there's 2 solutions. And then when I minus j is equal to 2, there's 99 ways and 3 solutions. And we can continue this casework. However, we notice that when j is equal to 0, x equals 0 is not a valid solution. So afterwards, we need to subtract the one solution for the probability that j is equal to 0. So this is just 100 over 101 choose 2. So we can group this as 100 times 2 plus 99 times 2 plus all the way to 1 times 2 plus 99 plus 97 all the way to 1 minus 100. This is equal to 100 times 101 plus, we can use the formula for the sum of consecutive odd squares. So there are 50 terms here, so it's 50 squared minus 100 which is equal to 1 over 101 times 50, 100 squared plus 50 squared. And so this is equal to 250 over 101. And that's our answer.